Let's take these limiting reactant calculations one step further. And in addition to calculating the theoretical yield, let's find how much of the excess reactant was left over. How many grams of silver bromide are produced from 50 grams of magnesium bromide and 100 grams of silver nitrate, given the following balanced equation? How much excess reactant remains? Before we get started, let's make sure that all of our coefficients are written in. I'm going to add 1 to each of those. So the first step is the same as before. We have to calculate the mass of product formed from each reactant. So this is going to be a mass calculation, starting with the mass of our reactant in question and solving for the mass of the product that we're interested in. So we are given 50 grams of magnesium bromide and 100 grams of silver nitrate. So we will treat each of those separately to see how much product forms using each of those amounts. So all of these are going to be a 3-step conversion problem. So I need to set up my 3-step conversion template. In each of these, I'm going from the mass of reactant, converting to the moles of that reactant, then converting to the moles of product, and then the mass of the product that we're interested in. And in this case, that product is silver bromide. So those are my 3 steps. So I'm going to start with magnesium bromide. I have 50 grams of magnesium bromide. And I can place a 1 there. The first thing I need to do is convert to moles of magnesium bromide from grams of magnesium bromide. And the molar mass of magnesium bromide is 184.1. That is what you get when you add the weight of 1 magnesium to the weight of 2 bromines from the periodic table. The next thing I need to do, now that I have canceled out grams of magnesium bromide and converted to moles of magnesium bromide, is I need to convert the moles of magnesium bromide to moles of the product that I'm interested in, which is silver bromide. From the equation, for every 2 moles of silver bromide I produce, I had to use 1 mole of magnesium bromide. The last step, now that I have converted moles of the reactant to moles of product, I need to convert the moles of product to grams of product. And for that, I need the molar mass of silver bromide. 1 mole of silver bromide is 187.4 grams. That's what you get when you add the molar mass of silver to the molar mass of bromine from the periodic table. So everything that I need to cancel cancels, and I'm left with grams of silver bromide now to do the math. So 50 grams divided by 184.1 grams. That gives me moles of magnesium bromide, then times 2 that gives me moles of silver bromide. Then multiplying by 187.4, that gives me grams. And I am going to keep 3 significant figures, so I'm going to round up to 102 grams of silver bromide. So that's how much we can make from 50 grams of magnesium bromide. Let's do the same thing with silver nitrate and see what we get. I'm going to use the same exact template, my 3-step conversion, multiplying by the 3 conversion factors. I can put almost the exact same things in these boxes, except I'm starting with 100 grams of the other reactant, so silver nitrate. I'm converting grams of silver nitrate to moles of silver nitrate. Then I'm converting the moles of silver nitrate to moles of silver bromide. And then I'm converting moles of silver bromide to grams of silver bromide. And I want to make sure everything cancels. So grams is canceling there. Moles of silver nitrate cancels here. Moles of silver bromide cancels there. And I'm left with grams. Now I need to fill in my numbers. The molar mass of silver nitrate is 169.9. Oops, that should be 9. So for every mole of silver nitrate, I get 169.9 grams. And then looking up at the equation, the coefficient in front of silver bromide is 2. The coefficient in front of silver nitrate is 2. So actually that cancels, so I could skip that step in my calculations because 2 divided by 2 is 1. So I don't need to do anything when the molar ratio is the same. Lastly, the molar mass of silver bromide, again, is 187.4. So the last step is identical because you're converting from moles of the same thing to grams of that same thing. So let's do the math. Starting with 100 grams, dividing by the molar mass, 169.9. I'm skipping the middle step because multiplying by 2 and then dividing by 2 gets me back to where I started. So then I just multiply by 187.4 and I get 110.3. And I can actually keep 4 significant figures because my starting number 100.0 had 4 significant figures. So in this case, when I start with 100 grams of silver nitrate, I get 110.3 grams of silver bromide. So comparing these two numbers, the smaller one is 102. So my limiting reactant in this case is magnesium bromide, because that gave me the lesser amount of product, and the theoretical yield, or the maximum amount of product I can make, is 102 grams of silver bromide. But now we have another question to ask or answer. We need to figure out the excess. So the way we do that is to figure out how much silver nitrate reacts with 50 grams of magnesium bromide. So this is another mass to mass calculation, but instead of mass of reactant to mass of product, we're going mass of reactant to mass of the other reactant. So what I'm doing here is I need to go from grams of magnesium bromide to moles of magnesium bromide, then to moles of silver nitrate, then to grams of silver nitrate. So it's just like we did above with the product, but now we're using the other reactant. So I'm starting with 50 grams of one reactant, which is my magnesium bromide. I need to convert that to moles of magnesium bromide. Using the molar mass again. And then I need to convert that to moles of silver nitrate. And then converting the moles of silver nitrate to grams. So, checking to make sure everything is set up correctly. Grams of magnesium bromide cancels, moles of magnesium bromide cancels, moles of silver nitrate cancels. I'm left with grams of silver nitrate, which is what we need to do to figure out how much of that actually reacts so that we can figure out how much is left over. I need to fill in my numbers. The molar mass of magnesium bromide we used before, for every mole, it's 184.1 grams. Looking back at the equation, if I scroll up here, the ratio between magnesium bromide and silver nitrate is 1 to 2. So it is 2 moles of silver nitrate for every mole of magnesium bromide that reacts. And then we need the molar mass of silver nitrate, which we used before, is 169.9. Now we do the math. Starting with 50 grams, dividing by 184.1, that gives me moles of magnesium bromide. Multiplying by 2 converts that to moles of silver nitrate. And multiplying by 169.9, that gives me 92.2 grams of silver nitrate that react. So that amount is how much silver nitrate actually reacts when you only have 50 grams of magnesium bromide. Now we have to figure out how much is left over. We started with 100 grams of silver nitrate. We subtract the amount that actually reacted, which is 92 point, should have been 3 if I round up. Let me change that real quick. 92.3 grams. And that gives us 7.7 grams left over. That did not react.